Dámy a pánové, tady je Sara Polak a vítám vás u dalšího dílu Technology Foresightu. Tentokrát to bude anglicky, já bych se mohla pokusit do francouzštině, ale myslím, že by jak Pierre, tak moje bývalá učitelka francouzštiny asi dostala srdeční záchvat z toho, jak mi to nejde, takže přepneme radši do angličtiny, to pro mě bude bezpečnější. A chtěla bych tady přivítat Pierra z Big Codeu, který nám řekne něco o ERKu, jak s tím pracuje, jaké tam mají výzkumné záměry, protože celá ta výzkumná skupina je naprostá pecka, tak se budu těšit, že to s námi takhle budete hezky sdílet. So switching into English, Pierre, welcome.
Hello, hello.
Hello. You were our first guinea pig because we actually did the first ever Technology Foresight video with you that never ended up being used, but maybe when we release a DVD you can watch the extras. Yeah. But this is 9 months ago. Since then you got married. Congratulations.
Yeah, thank you.
It's very cool. But tell us, those of us that haven't heard about Big Code, it's an incredible research group that's focusing on the study of programming languages under Jan Vítek. It's a very multidisciplinary group and you focus on R there. So if you could just briefly tell me and the viewers, what you do and what you focus on.
Sure. So Big Code, there is the word code in it, so we study programming languages for sure. And we study it on a large scale, that's why it's called Big Code. And it's a project which is led by Christoph Kirsch and Jan Vítek. And so we mainly study the R language in this project. And the R language is a language which you might not know if you're a student here, because you study more serious languages. But if you do data science, if you do statistics, if you do bioinformatics, then you might know about R. And this is a language which is dedicated for this kind of statistical computing. And so it has some downsides, it's not the well-designed language you would like to use. And so in the team, what we do is that, so we have two main parts of the group working on R. One is trying to optimize the language. And so for that, we have a Jit Compiler, and we can speak more about it later. And the other parts in which I am is more looking at large amount of R code. So we have millions of lines of code, thousands of libraries, and we are trying to find insights about how people now use R and how we can improve on that. And so we do large-scale analysis, and so also in the group there are people who actually create tools to gather millions of lines of code and to gather them according to some criteria. And so maybe you heard about GitHub, which is a repository of many different projects, open source. And so we can write queries and gather some projects according to some criteria, and then do some statistical analysis about that, not only in R, but in JavaScript, and so on and so forth.
Nice. Yeah. What fascinates me about your group is that I used to study linguistic anthropology as a part of my degree as well. And it's really interesting, even if you look at, for example, natural language processing and understanding the semantics between human language, but then of course the programming language, because you're communicating with the computer and fundamentally it boils down to zeros and ones, but you're trying to find the most effective way of getting the kind of algorithmization of the problem across and making sure that it's as precise as possible. In terms of R, you mentioned the downsides of it as a programming language in certain aspects. What are those?
So, if you are a programmer, what wouldn't you like in R? Many things, but there are many inconsistencies in the way it is, in the errors it shows, in how it coerces from one type to another type. It's slow. It has object systems, but I said object systems, so there are various ones and not only one, and each of them is not really part of the syntax, but more like something added, built upon some basic structures of the language. And also it's a language where you can do metaprogramming, but in a way which is not the usual macros that you may know, but where you have a function called eval, and with this function, you can evaluate whatever you want, any piece of language, and so you can really shoot yourself in the foot, and you can do like you have a lot of power, but you can really misuse it. I would say.
And so with these downsides, like obviously, like all languages and programming languages evolve as well. Has the R community somehow put together things in place that prevent these things from happening, or that make it more effective in certain?
Yeah, I would say so. Yeah. So I think the main initiative there is not really in modifying the language, but more on bringing function libraries that promote more safer ways of programming, or more nicer APIs. And so there is something called the tidyverse, like tidy, and which tries to make you program with R in a tidy way. And so it's a whole ecosystem, and they are really becoming widespread and used. And so now some people actually learn how to program in R, but with the tidyverse.
Nice. And so in terms of the research group, what has been like the main thing that you're maybe proud of that you've achieved there, or like one of the things that maybe you really want to crack but you still haven't managed to? About what we've done so far, it's so we studied this function called eval, which is really at the center of all metaprogramming in R. I can give more details about metaprogramming. Maybe I don't know if it's that'd be great. Yeah.
So metaprogramming is when you want to create functions that create pieces of code. So you want to generate new pieces of code from your program. So instead of writing, imagine you want to write functions that process a database, and you would have to like customize your functions for each of the columns in the database. If they are columns. But maybe you want to generate these functions. You don't want to write them yourself, but you want to code generate them. And that's actually a part of metaprogramming. And usually we call that macros, when we can generate code. And so in R, to come back to R, people use eval for that. And we wanted to see how people use eval, to see if they use the eval in a difficult to predict way, or if we can, if we could remove these evals and replace them by safer versions, basically. And so for that, we looked at all CRAN. So CRAN is the kind of library of R, where you have ten of thousands of packages. So you can find a package to study archaeology. So you have
I like that.
So you have statistical functions for archaeologists, for instance. So you have finance, whatever. And so we download all these packages, and then we run the code inside. Because a good point about R is that each package is documented and has a kind of manual and also pieces of code that you can execute. And so we take advantage of that to run and dynamically analyze R. And then we see when people use eval, and we can categorize that, and then we were able to find out how people use eval. And so we published a paper about that in a conference called UPSA. Yeah, so that was a nice achievement.
And what were your findings, by the way? I'm curious.
So the findings, a good point. To sum up, people were using eval mainly in the same way. So we actually divided the code into what users do, like the statisticians, the ones who are not programmers do, and the ones who build the libraries, these packages. And so the one who are programmers, who just like archaeologists or statisticians or economists, they don't use eval. They don't want to touch that. The one in the libraries use eval. And they usually use it in the same way. But sometimes it's useless. You can remove it. And also, like just for the fun story, when you want to publish a package in this big library, then there are some automatic checks, and they want to know if you are using or not some functions which are dangerous. and you are prohibited to use these functions. But if you really want to use this function, then you can not write it, but write pieces of them, and then use eval to create the function after. And so that it's hidden. So we found that, and so people use eval sometimes to escape automatic checks for safety.
Nice. So it's like an internal hack, basically.
Yeah, exactly. Yeah.
Right. Wow. And so this for me is fascinating. Like, would you say that R? I mean, how long has R exactly been around? I'm curious, like, whether it's evolved in the sense that maybe like not the syntax change, but like whether new hacks like this were used to make it maybe more of a versatile language than it was originally intended.
So it's a very old language. I don't have the date in memory, but I think it's like beginning of the 90s, maybe 1993. Like it evolved from a language called S, and which was built in. I don't remember all the details, but anyway. So it's very old, and it has very old code also. So the code quality or the code practices of some packages are quite old and sometimes outdated. And yeah, so I mentioned this tidyverse, so they are bringing new practices and new ways of doing it. Yeah, so nice. Languages evolve, and actually it's also the title of another project we have called ELE, which is Evolving Language Ecosystems. And so, yeah.
This is fantastic. So basically, like, you take a language that is, you mentioned old, that's still younger than me, and I feel, oh my God, yeah, I feel very bad now. But I'm joking.
And for a language, it's very old.
Yeah, thank you. For a woman, it's like the peak of your years. It's that psychological point when you suddenly celebrated 30 and you're like, oh, I'm getting old. But essentially, like, you had an original language that was scripted for a particular type of problem, dealing with large data set statistics. And what really fascinates me is the evolution of the whole ecosystem. Within your research group, do you even, I know it's difficult because you're kind of like comparing apples and oranges, but like, do you find the kind of similarities in the way that various languages evolve, like side by side? Do they have effect on each other, or are they very isolated ecosystems?
Well, I would say, yeah, they do evolve. I mean, they try to take some new developments from another one and bring it to that, or they have to adapt to the new platforms. And for instance, a big effort that has been undertaken for R for now a few years is to port it to UTF-8. So it's an encoding, and we have someone in the team actually, Tomasz Kelebera, who is part of the R core team, so the people who oversee the development of R. And he's busy now working on supporting UTF-8 in Windows for R, which is apparently very complicated. So it happens. And also, it's about types. So I will maybe speak about types a bit later. But so we have we have languages which have types by default, and static types. In C, you write int and then the variable name. So you want this variable to be an integer, right? And then in other languages, such as Python or R, you don't specify the type. But people have started to realize that it might be useful to give a type to a variable, like statically, and to be able to check before execution those types, and to see if they make sense, if you are adding a number and characters, for instance, or not. If you try to do that, it should fail now and not when you are running this program in a plane. Right. And so people have added types to Python, for instance. So you can add annotations, and then you can check them with some tools, for instance, MyPy. And so now also we would like to do that for R.
So is that your kind of like next research aim, like implementing those types?
Yeah. So that's really our goal, I would say, for the next year.
For next year,
Yeah. So we started. Actually, some people on the team published a paper about a very simple type system for R last year, but it only covers some cases, and we want to extend it. And we have worked so far on trying to see if it's possible to do that for R, or if we need to have a restriction of the language. And so for that, what we've done is that we have created a database of values from R. So we run millions of lines of codes. We record all the values, and we get maybe 200, 1 terabyte of values. Mm-hmm. And then we use a technique called fuzzing. And fuzzing is to try to randomly generate calls to R functions. And for that, we pick values from the database. And so the values already exist, or they are supposed to be valid values. Mm-hmm. And then we can generate all those calls, and we try to see if the calls succeed or not. If the calls succeed, then we record the type signature. So we record all these annotations on the variables and on the return type. And we say, okay, this works for these types. And we've realized for one function, for one given function, we can get thousands of type signatures, different ones, which is very bad because if you want to have a type system, you want to have your type signature to be short and to be easy to grasp for the programmers, mm-hmm. right? And so this preliminary work shows that we really have to restrict R to a version that is amenable for typing. Mm-hmm. Typing.
Nice.
So we've submitted an article about this kind of fuzzing, and we are waiting for the results.
Oh, fingers crossed. When do you get the results?
18th of September.
18th of September. Yeah. So by the time you're watching, maybe it'll already have been confirmed. So I'll have everything crossed for you.
So we know that, and then after that we will design the actual type system, mm-hmm. And we will handle all the challenging part, interesting part in R about types is, there are two interesting parts. The first one is it's a language where the vectors, or let's say sequences of data, are first-class citizens. Mm-hmm. So it's not one number; it's always several numbers at the time because it's a language for statistics. Mm-hmm. So we compute on arrays on sequences of numbers, on matrices. So the first question is how to design a type system for this kind of sequences, and also for something called data frame. Mm-hmm. And a data frame is a kind of table with names, column names, a bit like Excel, mm-hmm. actually. And by the way, Excel also is a language, and you also have data structures, and you could also type and have a static type system for Excel. So that's the first interesting part, and the second part is that you have in R you have functions that have the same name, but they operate differently based on the class of the object. Mm-hmm. For instance, you have an object that represents a statistical model, and you have another one that represents a plot, a figure mm-hmm. plot, and the function has different versions depending on the object, and that is a bit challenging to type. So that's another interesting part.
Yeah. This is fascinating because I'm curious as well. I was talking to Christoph Kesch mm-hmm. some months back, and mm-hmm. He was telling me about how he's getting more interested in quantum computing and things like that. So I know that there's a lot of you have a very rich ecosystem in your research group. Mm-hmm. So are you all working towards one end? Is there something that you're all trying to crack just from different perspectives, or I'm curious why you joined the group in the first place.
Yeah, so for the first question, do we have an goal? I think in research we get a funding with some end goal, mm-hmm. but then we can have some different ideas, and then we will diverge a bit, and so for the first, I think I'm not sure quantum computing is totally related to what we're doing now.
Yeah, exactly. Yeah.
Even though I know that Christoph wants to use that for symbolic execution, mm-hmm. and which is a technique to analyze code mm-hmm. again. So there is some links. There mm-hmm. are some links. We could use that to analyze some code, mm-hmm. but most likely on C code, which is something which is which is easier to analyze with these techniques. Mm-hmm. Whereas R is more dynamic and it's difficult to analyze with this kind of techniques. Basically. Mm-hmm. Mm-hmm. even though maybe with quantum computing, maybe it becomes much easier. Well, that's the first one. And for me, why I joined the team actually thanks to Christophe. And I wanted to work on programming languages. And the group actually, maybe I would say the link is programming languages.
Yeah. Because the reason why I'm asking is that I'm always, you know me, I'm always interested in like the different multidisciplinary links, etc. And something that I've been really noticing lately, you know, like maybe a year ago, 2 years ago, when people were asked like, oh, what should I go and study? Like the first kind of response would be, oh, go and do programming. You know, there's a lot of money in it. It's great. And lately I've been at a couple of conferences where they were talking a lot about low-code, no-code solutions. And what I'm interested in is the psychology of the ecosystem, where you have the complexity of the programming languages on one end. Learning them is one thing. I think analyzing the like almost linguistic properties is another, what you guys are doing, which is, I think, a beautiful science. But then you have this dawn of low-code, no-code solutions where, you know, does that mean, do you think that programming languages will ever become obsolete? You know, like assembly once was like the only way to get to talk to a computer, and then it kind of like the levels of abstraction got more intense. I know it's very difficult to predict the future without being like, you know, one of those astrologists with the crystal ball. But how do you see like the market evolving, or like the accessibility of programming languages for the general public as well?
Yeah.
It's a big question, I know, I'm sorry.
Sorry. Okay, so yeah.
That's
I should
totally
have put
fine.
it on the...
They're very busy at Big Code, now you can see, you know?
I think the first remark I would like to say is that in programming languages themselves, you have like a spectrum from the low-level languages to the high-level languages. And assembler actually is still used. Like, if you want really to program like really low level, like you want to have a specific platform, a specific CPU when you want to program it. And then you can go more and more high level. And so when you reach Python or R, it's already quite high level. And like for R, it's gonna really be used by people who are not programmers at all. Like economists, I'm helping sometimes an economist, a friend who's economist, to do some analysis and to tell him how to use R, and to he doesn't know anything about functions, about types, and so on. And so like these people use these functions more like a toolbox, I would say. And they don't know about the concepts behind, about loops, about conditions, and so on. So then, if you just see the language as a toolbox, then you can hide it behind some graphical interface, for instance. But I think also that there might be something interesting on this low-code, no-code direction, which is now with machine learning, you can try to synthesize code. And you can hide the synthesized code to the user, by giving some examples. So you give the examples, and then you can try to create some code. And I think that there are some works to do that, for actually generate some statistical functions. Or you give some sequence of number, and then you want to generate the function that creates these numbers. That could work, but it's gonna always be very specialized, dedicated. I think you will always have this kind of no-code for a very specific task. I don't see a general no-code language. You know.
Yeah, and
I cannot imagine that.
It's always with machine learning when people are like, oh, it'll solve all the problems. Like, yeah, very specific solutions. But it is interesting when it's like with, you know, GPT-3 generates you like a paragraph of text. Well, this can generate you code. One more thing I wanted to ask is, because this is technology foresight, so we're looking into the future. I remember this was before Christmas, actually, in 2021. God, we're in 2022. And Christoph Kirsch gave me the paper they were submitting with the quantum computing angle, which was like super cool, and I pretended I understood everything. What's Jan Witek up to these days? Because I remember I spoke with him, this is again like a year ago, on the coffee, the kind of technology festival here at the faculty. So what is his main angle now? What's he driving at?
Yeah, so he also works on R, and I think he's... So he worked with us about this eval study, about the types, because he's like the one who leads our efforts on R. So he advises us. He knows how to write papers and to have them accepted, for instance. So he always, help us write. He's mainly involved, I would say, in the effort about optimizing R. So we have something called a Jit Compiler. And the goal is to run R and analyze during execution how it's going, what's used the most, for instance, and then optimize, that's to say, to compile in a more efficient way the code that is mostly executed to generate better code. And so this is called Usher.
Brilliant.
Like the Czech letter. Yeah.
I like it. I love these like kind of almost sadomasochistic like aspects of research where you're like, it's already complicated. Why don't I just call it
exactly? And it's we use Slack and we had the channel called Show with the letter, but then it broke some of the APIs and we had to rename it to RSH. Because it didn't work.
I love it. Well, there you go, ladies and gentlemen. Pierre is not only got married again, congratulations. So you lead a much more active, fun life than the rest of us. But he's also the genuinely like Big Code. Please look them up on the faculty website because it's absolutely phenomenal stuff that they do. And even if you're not studying computer science or mathematics and you think, oh, this is actually quite divorced from what I do, absolutely not. Because like the human language and analyzing language is understanding how people think. Orwell always used to say, if you can't say it, then you can't imagine it. It's the parallels with the programming languages are just fascinating. And I wish you every bit of luck with the upcoming paper and with your research. And of course with your marriage, but you don't need luck with that. Yeah.
Thank you. And yeah, if you're a student, we are looking for students, so come work with us.
There you go. That's a call to action. So let Pierre know if you're a student and you're keen to learn. And Pierre, I hope to see you here again and all the best with your research.
Thank you.
Thank you.
Thank you.
Au revoir.
Au revoir. Hasta luego.